This is the second video for arc length or length of a curve, and this video is going to have the examples that you're going to need in order to do some problems at the end. So let's, I'm going to do 2 examples with you, and hopefully that will be enough for you to do some problems on your own. So what I want to do first is consider this cubic, our parent function x cubed, from 0 to 5. Visually, what I want is this highlighted portion. I want the exact length of this curve right here. So what we're going to use is the arc length formula, which we derived in the previous video. And we're just going to plug into there. Now keep in mind, whenever we have f prime here, it's going to be the derivative of whatever curve you have, like the curve you're finding the length of. So my length of my curve is going to be my integral. A and B are the endpoints that you're on, so I'm going from 0 to 5. And I have the square root of 1 plus. Now the derivative for this one's very easy. It's just 3x squared. Sometimes they're going to be a little bit more involved than that. And I have dx. So let's just simplify. At this point, we need to clean up whatever is under the square root. So 3 squared is 9, x squared squared is to the 4th, and dx. Now, you could stare at this integrand for a really long time here. We don't know how to do the antiderivative of this. It's not a simple one. You can't do parts. You can't do partial fractions, U sub, long division, anything. So sometimes on the AP exam, all they're going to want you to do is do the setup just so that you can prove to them that you know what the formula is. That's mainly what they care about. And you'll just stop right there. And again, just make a note of this, is the arc length often leads to messy integrands. Here I have the arc length formula often leads to a messy integrand. And again, this is your integrand, the thing after your integral. So on the AP exam, they will either have you just set it up, or it'll be a calc active problem, and at this point you would just type it into your grapher with Math 9 and get a decimal answer. So what I'm going to show you next is one that we can do all the way by hand, and they do have some questions like this on the exam where you do need to do it out by hand. So we're going to take this, which is not a polynomial, and because I'm mixing x to the 3rd and x to the -1, I'm going to zoom in on the part of the graph that's from 1 to 3. So it's an interesting graph here. We only care about the portion from 1 to 3, and the graph looks something like this. It reaches a minimum at around, whoa, like that. There we go. So I want this portion, 1 to 3. All right, so let's get our arc length formula. Integral from a to b. Now this is a formula you do have to have memorized. It's not too difficult to memorize. It's just that you have several other things you need to memorize. So the more that you practice, the more it'll be committed to memory. And this one here, my derivative is just one step more involved than the other one. So I'm going to do my derivative on the side before I plug into my formula, just so that it's a little cleaner when I actually plug into here. So I bring down the 3 tells is 1/4 x squared. Bring down the -1 to the -2nd. So I have 1/4 x squared minus 1 over x squared. So what I'm going to do is plug that into the formula here. So I have the integral from 1 to 3, and I have the square root of 1 plus this squared dx. All right, so you might be looking at this thinking, wow, that looks really ugly. There's no way I can do this by hand. But you can. And again, because this is going to involve some side work, I'm going to do this squaring over here so that my integrand will look a little bit neater. 1/4 x squared minus 1 over x squared. And let's go ahead and FOIL it. And whenever you FOIL it, just watch what happens here. 1/4 x squared times 1 over x squared, your x squareds will cancel. Same thing right here. 1/4 x squared times 1 over x squared is just going to be -1/4 plus 1 over x to the 4th. So this is 1 over 16 x to the 4th minus 1/2, and then plus 1 over x to the 4th. So we're going to take this and replace it back into our formula now that it's a little bit neater. And then we're going to do something here that will allow us to do it by hand. Plugging back into our formula, we get this. And let's clean up the integrand even more. I have this 1 and I have this -1/2. So let's simplify even more. So I'm going to have the integral. 1 minus half is just half, so 1/16 x to the 4th plus 1/2 plus 1 over x to the 4th. This is still dx. All right, so the thing is, this looks like an integrand that we can't do because it's like, well, what's the antiderivative of this? The problem is the square root. If this square root was gone, then I could just do the antiderivative of this piece by piece. But the square root, we can't just get rid of it. The only way we could get rid of the square root is if I had something squared under it, because then they would cancel. So it would be really nice if I could write this as something squared, which basically means factor it. So I want you to pause the video and factor this right here. It's not too bad to factor. And then that will allow us to cancel our square root. Okay, so you should have factored this here, and it actually factors pretty nicely into this. The factors are the same exact thing, which allow us to write it as this squared. Now, if this looks familiar to you, it's because you basically just did it right here. The only difference is there was a minus. Adding 1 to our expression changed the factors just by a tiny bit and made it plus instead of the minus that we had up here. So now I'm going to write it in a factor squared, and that means you can cancel that. Hooray! My integrand just became a whole lot easier to deal with. So now we're looking at, I'm going to bring the x squared to the top dx. So now I can actually do the antiderivative of this. And antiderivative is going to be add 1 to that and divide by my new power. That'll make that 12. And add 1 and divide by it, so that would be minus x to the negative 1, or 1 over x, and I'm going from 1 to 3. So I'm going to plug in 3, and I'm going to plug in 1. So here's plugging into 3, or plugging 3 in, and here's plugging 1 in. Because we have to do this all by hand without a calculator, I wrote it all as fractions, not with these negative exponents, because they're kind of hard to think about unless it says a fraction. So let's get some common denominators here. I need this to be a 12, so multiply by 4, and I'm going to do minus 1/12 minus 12/12. So what I'm going to do is distribute that negative so that I can combine everything. Now it's all over 12, so I just have 27 minus 4 minus 1 plus 12, which gives me 34 over 12, which equals 17 over 6. Final answer. That is the length of our curve from 1 to 3. Whoa. 1 to 3 on this function. So as you can see, some of them you can't do all the way, some of them you can do all the way. It all depends on the integrand and whether you can do some kind of manipulation to get rid of the square root. It's really the square root that's the problem. So I have 3 U-tries for you. For these U-tries, I want you to do them on a separate sheet of paper. I'm going to collect them as you walk into the door in class tomorrow. And then we will practice arc length free responses tomorrow in your group. So again, on a separate sheet, please read the directions very carefully. If it says do by hand without a calculator, then I expect you to be doing work like this, because without a calculator, you would need to do that work. So by hand, this one, just do the setup. You'll see why when you see the integrand. And I will see you in class. Bye.